Hello, we are in Chapter 7, Section 7.3, Exponential Functions. In this video, we're going to go over problem number 6, in which we are to graph this exponential function that is shifted by first filling in the table. We are raising 2 to the power of x, so we are just evaluating the basic exponential function 2 to the power of x. But then, from that, we subtract 1. So we can start with looking at the values of 2 to the power of x for each input that we have in our table, and then we can subtract 1 accordingly. So starting with the exponent of 0, 2 to the power of 0 is equal to 1, and then we will subtract 1 from it, resulting in 0 altogether, giving us the first point on the graph 0, 0. When we raise 2 to the power of 1, we get simply 2, and then subtract 1 from it to get 1. Another point on the graph will then be 1, 1. When we raise 2 to the power of 2, we get 4, then we subtract 1 to get 3, resulting in another point 2, 3. And when we raise 2 to the power of 3, we get 8, and then take away 1 to get 7, resulting in another point 3, 7 on the graph. Now moving on to the negative inputs, 2 to the power of negative 1 is the reciprocal of 2, which is 1/2, but then we take away 1 from it. If we perceive 1 as 1 over 1, we can then multiply the numerator and denominator by 2, to have the difference of fractions with the same denominator, and then the numerator will be 1 minus 2, which is negative 1 over 2. So another point on our graph is negative 1, negative 1/2. Now 2 to the power of negative 2 is the reciprocal of 2 squared, which is 1/4. And then we subtract 1 from it that we also perceive as 1 over 1. This time we have to multiply the numerator and denominator of the second fraction by 4 to obtain fractions of the same denominators, and acknowledge that 1 minus 4 is negative 3, so negative 3 over 4 will be our result in here, giving us another point on the graph, negative 2, negative 3/4. And finally, if we raise 2 to the power of negative 3, we get the reciprocal of 2 cubed, and 2 cubed is 8, so it's 1/8. And from that we subtract 1 that we also perceive as 1 over 1, and this time the common denominator will be 8, so we multiply both the denominator and numerator of that 1 over 1 fraction by 8 to obtain fractions of the same denominator. 1 minus 8 is negative 7, so we get negative 7/8 as the result in here, giving us another point, negative 3, negative 7/8. Now we have enough points to join them with a nice smooth curve that extends in both directions. And we can identify the properties of our function. The domain, as for all basic exponential functions, is all real numbers, since we have no constraints for the domain, so the interval from negative infinity to infinity. For the range, we scan the graph vertically to check what y coordinates of the points on the graph, that means values of the function, we have. It looks like the graph here at the bottom is tending towards the value of negative 1, never reaching it, so it will be from negative 1 then up to infinity, open. And horizontal asymptote is the horizontal line over which the graph is hovering, and it looks like in here it's below the x-axis at the level of negative 1, so it's y equals negative 1.